So now we're going to talk about some composite cylinder cases. And this is the next in a line of videos that we've talked about, looking at the Gaussian application for various different things. And so far we've looked at solid cylinders, and we've looked at thin shells, and then we looked at thick shells. When we have a composite cylinder case, what I'm really talking about here is we're going to have the electric field due to several things, all of which have a cylindrical symmetry. So in this case, what I need to remember is that the net electric field is a summation of the original individual electric fields. So for example, I could have a straight line of charge at a R equals 0. That could then be surrounded by a thick shell from R equals A to R equals B. Surrounded by a thin shell not from, but at an R equals C. Now, to try and draw this out here, I'm going to say, okay, I've got a dot at the center surrounded by a shell surrounded by another shell. And we're going to have different regions here that we're going to have to consider. R equals 0 to A. R equals A to B. R equals B to C, and then R equals, or R greater than C, I should say. So by the supposition principle, if we're in this one, we only need the E1 from the line of charge, which there was a single equation outside that line of charge. If we've got this region between A to B, I'm going to have to find E1 from the line plus the E2 equation where I'm inside that shell. In this range, I'm going to have my E1 equation plus my E2 outside equation. And here, I'm going to have E1 plus E2 outside plus E3 outside. Now, technically, I always have E1 plus E2 plus E3. It's just that in this region, E2 and E3 were equal to 0 because I was inside the cylindrical shell. In that AB range, E3 is equal to 0, and I had an equation for E2 within the shell. In this region, still, E3 was equal to 0, but I had an E2 outside of the shell. And now none of them are 0, they're all contributing. Okay? And so it's just putting together pieces of the electric field due to those static charge distributions. So that's going to wrap up my cylinder discussion for applying Gauss's law.